Hi everybody, we have standard 15 parallel and perpendicular lines here. Here's our notes for this. Slope is hopefully something you remember from Algebra 1. It's often referred to as rise over run, which you see right here. I guess I don't need this here anymore since it's right there. Slope is often seen as an m. Because of the equation y equals mx plus b, you have that m there, and that's your slope. Slope is not only rise over run, you can also use the equation y2 minus y1 over x2 minus x1 when you have the points to calculate your slope. Rise over run would just be when you count it, which is what I did to get 3 over 6. So I found this point, and I'm going to this point. I see that I went up 1. Let's count this out better. I started here, counted up 1, 2, 3, so that's where I got my 3. I counted to the right 1, 2, 3, 4, 5, 6. So that's where 3 over 6 came from. Now, of course, I could simplify this so that m actually equals 1/2. 3 over 6 is the same as just half. Okay, here's an example. I went ahead and put my equation over here, y2 minus y1 over x2 minus x1. That's how I find slope. I figured out what each point was. So S's coordinates are -3, 7. I figured that out by counting -3, -1, 2, 3, and up 7. So that's why I got -3, 7. I'm counting that as my x1 and y1. -3 is my x1, 7 is my y1. Point T is -1, -1. So to the left one and down one, -1, -1. That's my x2 and my y2. I went ahead and plugged that into my equation over here. So slope equals -1 minus 7 divided by -1 minus -3. Notice I had to do minus still, and then the actual number, minus -3. -1 minus 7, that gives me a -8. And if I do -1 minus a negative, that's the same as -1 plus 3. -1 plus 3 gives me 2. -8 divided by 2, that's the same as -4. So my slope in this equation, or this graph, is -4. Alright, I found my points for my second example. G is -2, -5, which is x1, y1. F is 6, 2, so I went to the right 6, up 2. That's my x2, y2. And then I went ahead and plugged it into my equation, y2 minus y1 over x2 minus x1. So my y2 is 2 minus -5, so 2 minus -5. And then I have 6 minus -2, 6 minus -2. So 2 minus -5, that's the same as 2 plus 5, so 7. 6 minus -2 is the same as 6 plus 2, which is 8. Then I went ahead and actually counted from point G to point F. When I do that, start at G, I count rise over run, so I counted up 7 squares. That's my rise, my numerator in my fraction. I counted to the right 8 squares, so that's where I got my 8, my run. This should always happen where your counting results in the same slope as your actual calculation. So this was good. Everything was done right because we got the same answer for both. Something people often forget is what positive, negative, zero, and undefined slopes actually look like. So positive slopes, if you start on the bottom left and you're heading up and to the right, that's a positive slope. For negative slopes, if you're starting at the bottom right and moving up to the left, then you're at a negative slope. A zero slope, if you come up with some number like 0 divided by something, 0 divided by 5, for example, then you have a zero slope. If you ever see a horizontal line, that's a zero slope. Undefined slopes are always the vertical lines. If you come up with something where you have 5 divided by 0, for example, or some number divided by 0, then it's undefined. You can never, ever, ever divide by 0. So that's why you have an undefined slope at that point. Okay, Most of this is taken directly from 3-3 in your textbook if you want to be looking in there for some more references. Go ahead and fill this out on your note guide. Hopefully you've been filling it out, the missing pieces as we've gone along. Okay, one thing you should know about parallel lines, their slopes are always the same. If you look at lines L and M over here, L and M, we do have our parallel line arrows on it. That's a good thing. It shows us they're parallel. But more than that, our slopes are exactly the same. The slope equals 4 for both of the lines that we're looking at. So if their slopes are the same, that means they're parallel. Okay? In this case, line L, let's make that look better. L is parallel. So if you see two tall lines like that right next to each other, that means parallel to line M. Line L is parallel to line M. That's because they have the same slope. Slopes of perpendicular lines, those are opposite inverses. In this case, line M is perpendicular to line P. So we see line M and line P, they have that box to show they're perpendicular. And we see that they are opposite inverses of each other. We see that because we have the slope is 4 for line M. We have the slope is -1/4. So what we do, we take our 4, we flip it. We flip it if it was a fraction. As a fraction, 4 would be 4/1. So we flip it to make it 1/4, and we change the sign. So positive becomes the negative. So 4, -1/4, those are opposite inverses. So that's -1/4 and 4, they are perpendicular lines. Okay, so just a little practice here. If I had a slope of 2, my parallel line would have a slope of, it has to be the same, so also 2. If I was looking at perpendicular lines, my slope, I would make it the opposite sign, so negative, and then I would flip it, so I have, instead of 2/1, I have 1/2. If my slope was -7 for a line, parallel would mean it would have to stay -7. The slopes stay the same. For perpendicular, the sign would change, so it would now be positive, and you would flip that 7/1 to become 1/7. If my slope was 2/5, the parallel line, it would be the same. The perpendicular line, change the sign, so now negative. I flip my numerator and denominator, so 2/5 becomes 5/2. If my slope was -4/9, and I wanted a parallel line, it would stay the same. Perpendicular, sign changes, so now positive. Flip the numerator and denominator, so now 9/4. Okay, we have to determine whether or not line FG and line HJ are parallel, perpendicular, or neither. So I think about my equation, y2 minus y1 over x2 minus x1. Let's go ahead and copy that over. Here's my equation. if I look at points F and G, one of those will have to be my x1, y1. One of those will have to be my x2, y2. So for FG, let's see if I can write this with it being looking okay still. FG, I have y2 minus y1, so my slope equals y2 would be -1, I got that from G, minus y1, my -3, all over -2, which is my x2, minus my x1, which is 1, so -1, equals -1 minus -3. That would be -1 plus 3, which is a +2. -2 minus 1, that would be a -3. Now let's figure out the slope of line HJ. Okay, identify my y1 or my y2 first. My y2 would be 3. Then I'd have minus my y1, which would be 0 here. Then over 6, because that's my x2, minus 5, that's my x1. 3 minus 0, of course, is 0. 6 minus 5, of course, is 1. 3 over 1, that's the same as just 3. So, parallel, perpendicular, or neither? Well, let's compare my slopes. -2 over 3, +3. Well, I have opposite signs, so maybe it could be perpendicular. But I don't have the inverse. 3 over 1 is not the inverse of 2 over 3. Okay, if I had instead -1 over 3, that would work, but that's not what I have. So my answer here is going to be neither. They're not opposite inverses, and they're not the same as each other. Okay, last example on your paper. Write an equation for a line that passes through the point 0,5 and is parallel to the line created by 2, 4 and -1, -2. Okay, first of all, I can plot my points. 2, 4. That'll be here. -1, -2. That'll be this point right here. So, it's going to be tricky. You should use a straight edge. Making my line go through those points that I just plotted, which were here and here. Put arrows on the end. Okay. Now I need a point, or I need a line that passes through the point 0,5 and is parallel to this line. So, passes through the point 0,5. It has to pass through this point right here. Parallel means I need the same slope. So let's figure out my slope of this line right here. If I just think about rise over run without actually plugging it into my formula, rise over run. I start at this point, go up 1, 2, 3, 4, 5, 6. So my current slope is 6 over. Then how many do I go over? 1, 2, 3. 6 over 3. 6 divided by 3 we know is 2, so my slope is actually 2. Let's count that one more time. 1, 2, 3, 4, 5, 6. 1, 2, 3. Great. And it's starting at the bottom left, going up and to the right, so that means I have a positive slope. So because I'm looking at parallel lines, I want my slope to stay the same. So my new equation is still going to have a slope of 2. So I already know it's going to be 2x y equals 2x plus something. I just need to figure out what that b is, what that y-intercept is. Okay, lucky for me, it's already on here. I already know my y-intercept is going to be b. All I would have to do is graph it now. If I think about this, 2, this could be written as 2 over 1. So I could go up 2 over 1, or I could go down 2 to the left 1, get the same results. And then if I put a point or a line through here, notice that it's parallel, never touching each other. Never ever touching each other. So my answer to this problem is right here. Y equals 2x plus 5. That's my answer. And then we're done.